Welcome back, and we're looking at some examples of integration. So all we do is just do the usual approach, okay? And what we're finding is that indefinite integrals are of the form dx, okay? Definite integrals have numbers above and below, okay? And that's the main difference. That's an indefinite integral. This is a definite integral. So we'll have a look at those next week. For this part, you can expect to see all of our integration signs without numbers, okay, and without us computing a particular value. We'll do that next week. All right, for this part here, we just want to generate plus c, so up and under. So the integral will become up and under. Easy. Wow. Okay, very good. For this one here, minus 6 stays out the front. 12 is going to become up and under. So we'll get minus 6x, the integral will equal minus 6x. 12 becomes plus 1, 13, and divide by up and under. Okay, here we're going to treat it like, now the brackets in this occasion are distractors. So we're just going to write it all out. Now we could write it as 3 separate and distinct integrals, but we're not doing that. Okay, we're just doing it together. So that will be up and under on each of them. So up and under, that will become 3x is 1, x plus 1 is 2, divided by 2. 3 becomes 4, so 3 becomes 4 up and under 4. Pi is not a variable, it's a constant, so it stays as a constant. x7, 7 goes up and under. Sorry, I don't know why I did that, but you'll go away, we're not ready to finish yet. So we've got plus pi x up and under 8 on 8, and don't forget your plus c. Very, very important. Okay, don't forget your plus c. Alright, so these are just very doable, aren't they? We're still not sure what they mean, other than that they're the inverse of those things. If I take one of these and I ddx x7 over 7 plus c, I would put the 7 out the front and take 1 off, and the constant would disappear. They would cancel, and I would be left with x to the 6. Oh, the fact that it had a cancel, look, so we did the inverse. So at the moment, that's all we're doing. We're just playing around with inverse operations. Just like we did with e and learn, and plus and minus, times and divide, square and square root, cube and cube root, all of those things. Now we're doing it with integration and differentiation. So if you're wondering what we're doing, we're showing this transformation from one form to another. Well, of course, the gymnastics will come in. That's to be expected. So we can, the brackets again are distractors, there's no powers. But this time we'll use our knowledge of indices, okay, to put that there and say that, oh, we've had a change of pronumeral. Does that matter? No, of course not. So it's still going to be up and under. So just be careful now, because t is to the power minus 6. Minus 6 plus what? Doesn't go that way. Oh, it goes this way, which means that we're going to go to minus 5. So minus 6 plus 1 is minus 5, and divide by minus 5. Oh, something's happened there. Did you notice that? And don't forget your constant. So finally, the integral is going to become positive 6t over 5. 6 on 5, just me being a long way, do it again, okay? And finally, we're going to get 6 over 5t to the 5 plus c. simplified, if you like. Okay, so we're just practicing our skills, getting through our inverse. If we differentiate that, we'll get this term up here. I'll leave you to practice doing that. Okay, bit of pre-work for these guys. So we're going to end up with an equivalent. Now, what's this one here? I've made a bit of a fuss about this in the lecture. What is that number? What is that? I gave it away, then I said it. It's a number. There's no x in that term. So that's a constant. If we integrate a constant, we're going to conjure the variable. Please write that down. Integrate a constant. Integrate a lone constant. We conjure, not a very nice word, I'll think of another one. Reduce the variable. Okay, it comes out of nowhere, which is why I'm using conjure. So x is going to appear in this term where before there was no x. Alright, so nothing to do there in terms of cleaning up. Here we've got 2 on 3 x3. Now be careful. What do we do with that? We multiply it, don't we? I'm going to do a whole new line just for that sake. Now we can integrate. Okay, the integrand is going to become what? 12e here. 12e x. What's the mass of that? X to the naught. Okay, x to the naught. A number has x to the naught next to it. Okay, so next one, up and under. Oh dear. Oh dear. Okay, it never goes away, does it? 3 on 2 plus 1. Okay, divide by 5 on 2 is equal to times by 2/5. So we're going to get 12e to the x minus 7x4 over 4 plus 2 on 3, 2 on 5 x to the 5 on 2 plus c. So that's going to be 4 and that's going to be 15. So we'll get 12e to the x minus 7x4 over 4, 4 over 35. And it's the x to the 5, the square root. Do you want to do that? Plus c. That is our final solution. So please be careful as you go. Okay? Please be careful as you go. Alright, I'm going to stop the video here and come back because I want to make a big fuss about this. Okay, so I'll pause that video there and we'll come back and have a look at substitutions. Simple day today. Thank you. See you soon.